Welcome to Homework Lib.
All right. In this problem, we are looking at workmen who are trying to free an SUV that is stuck in the mud. And I've already drawn part of the diagram that is shown in this problem. This black box here, is representing my SUV that is stuck in the mud. And there are 3 ropes that they are using to try and pull this SUV free. And they're all producing different force vectors that I'm going to draw on right now. The first rope that I'm using red to represent is pulling up and to the right with a force of 985 newtons. That's rope number 1. Rope number 2 is blue, and it is pulling up and to the left with a force of 788 newtons. And rope number 3, I'm using green to represent, is pulling with a force down and to the left of 411 newtons. And all 3 of these force vectors have some direction to them, and we're going to use angles on this XY coordinate system that I've drawn to talk about their directions. So for force number 3, we have an angle to the horizontal of 53 degrees. For force or rope number 2, we have an angle to the vertical of 32 degrees. And for rope number 1, we have an angle to the horizontal of 31 degrees, like that. All right, now that we've got our diagram drawn out, part A of this problem wants us to find the X and the Y components of each pull. So for each rope, we were given an overall force and direction, and we want to find the X and the Y components of each of those 3 pulls. We're going to start with rope number 1. And for rope number 1, I'm going to redraw that force, that 985 Newton force. And we're going to draw a triangle to help us figure out the X and Y components. And so F sub X is the X component, or the horizontal component of this force, and the F sub Y that I've drawn here represents the vertical component of the force. And so since this force overall is up and to the right, we know that it's being pulled to the right a little bit and up a little bit. And so we can figure out how much to the right and how much up there is in this one force. All right, so this triangle that I've drawn is a right triangle. And to find the 2 sides of this triangle, we're going to use SOHCAHTOA. Which is a trig mnemonic that helps us figure out, do we want to use cosines or sines or tangents in order to find different sides of right triangles. And we're going to start with F sub X, this side right here of this triangle, this X component. And since this side is right next to the angle, it's adjacent to this angle, I'm going to use the ka in SOHCAHTOA. So A stands for adjacent, H stands for hypotenuse, and C stands for cosine. And so my adjacent side divided by my hypotenuse is equal to the cosine of the angle, which means that F of X divided by our hypotenuse, which is 985, is equal to the cosine of our angle, which is 31 degrees. And then to solve for F sub X by itself, I'm going to multiply both sides by 985. So in your calculator, you would type in 985 times cosine of 31 degrees. And it is important that you are in degree mode on your calculator for this. And if you type that into your calculator, you end up with 844 newtons. And that would be equal to our x component of rope number 1. So to find the y component of rope number 1 or force number 1, we're going to try and find this side to our triangle that I've drawn. And that is the opposite side of the angle. So sides here, angles over here. And that would mean we want opposite over hypotenuse, which means we can use sine of our angle to figure that out. So f sub y divided by our hypotenuse, 985, is equal to sine of 31 degrees. Multiply both sides by 985. And you would end up with f sub y is equal to 985 times sine of 31 degrees. And so f sub y would equal 507 newtons. All right. And so all of this is the f sub x, or the x component, and the y component of rope number 1. Which means we have 2 more ropes to figure this out for. I'm going to take this information and move it to the side for now. All right, for rope number 2, we are doing a very similar thing. For rope number 2, we're going to draw another triangle. And first I'm going to start with the force that we drew in blue on that first diagram, where we have 788 newtons of force being pulled up and to the left. And we had this angle of 32 degrees to the vertical this time. And I'm going to label my 2 sides f sub x and f sub y. Remember, x is always horizontal, y is vertical. And we're going to do almost the exact same thing that we did last time. F sub x is the opposite side this time to the angle. And since it's the opposite side, f sub x over the hypotenuse is actually going to be equal to sine of our angle. So sine of 32. And that's coming again from SOHCAHTOA. So sine is the opposite side over the hypotenuse. Solving for just f sub x, we end up with 788 times sine 32, which is equal to 418 newtons. All right, f sub y is very predictable. We're going to be using cosine because it's the adjacent side. We're going to solve for f sub y on its own by multiplying both sides by the hypotenuse. And plugging that all into your calculator, you end up with 668 newtons. All right, so this is rope number 2. You have an x component of 418 newtons and a y component of 668 newtons. We're almost there, 1 more to go. All right, rope number 3. 1 more triangle, and this is that green vector that I'm looking at on the first diagram. We had that force of 411 newtons. And then I'm drawing the 2 sides of my triangle. My angle was 53 degrees to the horizontal, F sub x is my horizontal component. F sub y is my vertical component. And I'm going to start with F sub x again. F sub x in this case is right next to the angle. And so it's adjacent, which means I'm going to be using cosine. So F sub x over 411 is equal to cosine of 53. Multiply both sides by 411. And plug that into your calculator. And you end up with 248 newtons. And for F sub y, hopefully you've guessed it by now, we're using sine of 53. Multiply both sides by 411. And plug it all in. And you end up with 328 newtons. And this is all for rope number 3. All right. So it's quite a lot of steps, but they're all very similar for part A. For part B of this problem, we want to use the components that we just found to find the magnitude and the direction of the resultant of the 3 poles. And so what that's saying is it wants us to find the overall force of all 3 ropes combined, and we want to know what direction it's going to go overall. Because these ropes are all pulling in different directions, and they're all pulling with different amounts of force. And so, of course, when you add those all together, you're going to go in one direction and have a certain amount of force. Some of it's going to cancel each other out, just like if you pulled with tug of war, one way and another way. And so to figure this one out, I'm going to draw one more diagram. Here is my black SUV. And I'm going to add on all of these different components that we've just found in the X directions and in the Y directions separately so that we can kind of get a gauge on which way things are going. I'm going to start with rope number 1. We had rope number 1 pulling up and to the right. And so the F of X, the X component, we had 844 newtons and it was going to the right. And the Y component of that force was 507 up. For rope number 2, we had a F sub X of 418 newtons, and it was pulling to the left. So I'm going to have that force moving toward the left, so the opposite direction of my other F sub X. And the F sub Y for rope number 2 was 668 newtons upward. And for our last pull, we had it pulling down and to the left. F sub X was 248 newtons to the left. And then downward, it was, or F sub Y was 328. All right, so overall, when we're looking at all of these different forces up and down and left and right on the SUV, you can kind of already see which direction is winning out overall. Upward is bigger overall than downward, and rightward is actually a little bit bigger overall than leftward, even though they're close. And so that's helping us kind of get a realistic check on what we're about to find numerically using some equations, which is the magnitude and the direction of our resultant force. So to find the magnitude of this force first, we're going to use these different components that I've drawn on here to add together to get a total F sub y and a total F sub x. And so F sub y is what I'm going to start with here. So F sub y, we've got this 668 Newton force upward plus 507 force upward minus a 328 force or Newton force downward. And I'm subtracting it because it's in an opposite direction. And when you add and subtract those numbers, you end up with a total of 847 newtons upward. I'm going to draw an up arrow for now to represent that it's upward. For F sub x, we're going to do a similar thing. 844 minus 418 minus 248. And again, I'm subtracting because those are in opposite directions. And when you subtract those numbers, you end up with 178 newtons rightward overall. All right, so we have the x and y components of our overall resultant force. But to figure out just the force, the resultant force magnitude, we have one more thing we need to do, which is use this equation. Force, or the magnitude of the force, is equal to the square root of F sub y squared plus F sub x squared. Again, that's all square rooted. And I'm going to plug in the numbers we just found here. So we have 847 squared plus 178 squared. And then we are square rooting that entire thing. And if you plug that number into your calculator, you end up with 866 newtons. This is the magnitude of our resultant. All right, and we do have one last step, which is to find our direction of the resultant force, so the direction overall that this is going to travel. And to find that, we use the tangent of that angle, that direction we're looking for, is equal to F sub y over F sub x, where those are the components of the resultant force. And so since we just found those two numbers right here, we're putting stars, I'm going to plug those in. We have 847 divided by 178. And since this says tangent of theta is equal to 847 over 178, to solve for just theta, I'm actually going to take the inverse tangent of both sides. So that means that we end up with theta is equal to the inverse tangent of 847 divided by 178. Again, make sure you're in degree mode in your calculator, and you'll end up with 78 degrees. And so you might be wondering, what is that 78 degrees in reference to? And so one last little drawing here. Here's our SUV and our X and Y axis. That 78 degrees is from the positive X axis. And so it would be heading in a direction sort of like this, where we have 78 degrees counting counterclockwise from the positive X axis. All right. And so we have our magnitude of 866 newtons and our direction of 78 degrees from the x-axis overall. And that is the end of this problem.